In this video we are going to see how the logarithmic differentiation works and what that is. Sometimes we can have pretty complex in terms of or complicated functions that are not easy to handle with the usual rules like product or quotient rule or power rule or any other rule that we have. In that case, we can, for suitable functions and under certain conditions which are in general supposed to be fulfilled, we can use something which is called logarithmic differentiation, and it is done in basically two steps. First, we take logarithms of both sides, and then we differentiate both sides as logarithmic and hence composite functions. And then after the further simplification, we return the substitution and anti-logarithm so that we obtain the final result of differentiation. The whole goal of that is basically to make derivatives calculation less complicated, because some functions can be hard to handle with usual differentiation rules. So here is the first example. We have y equals x to the power 3, and then in the denominator square root of x squared plus 1. Now you can try and find this. So the natural step is to use quotient rule. But the problem here is that you see you have a square root function. Then inside the square root function you have x squared plus 1. So this is a composite function, which again, everything there increases the steps of calculations. So instead of going with the quotient rule and the composite function together, we are going to first simplify this function, and that is, we can write it as x to the power 3 and then square root x squared plus 1 to the power negative 1, and that we can write as x cubed x squared plus 1 in the brackets, x squared plus 1 in the brackets, the power negative 1 over 2. Now we know that it would be great if, now this is a product, but you see logarithm, when you take logarithm of a product, it becomes a sum, and sum is very easy to differentiate. So if we take logarithms, then we would get something which is easy to differentiate. So we can write here y equals x cubed x squared plus 1 minus 1 over 2. Now let us take ln of both sides. That is ln of y equals ln of x cubed x squared plus 1 minus 1 half. Now this ln, so the natural logarithm I will just make here. So rule says when you have ln of xy, that is ln of x plus ln of y. This is the rule for the natural logarithms or logarithms in general. So having this rule, that becomes now ln y equals ln x cubed plus ln x squared plus 1, and then everything minus 1/2. And we still can simplify this because we have another rule. Let's say this is rule 1, this is rule 2. ln of x to the power m is m ln x. So I will also highlight these rules. And here also. These rules are important for the applications. So I'll use another color. So we can now write this here. It will be ln y equals. So notice we are still now differentiating. We are just simplifying the function. Now, this we can write as 3 ln x plus minus 1/2 ln of x squared plus 1. Now this is much simpler to differentiate than the starting one. So this is very complicated. This here, so this function here is very complicated for differentiation. But we have managed using ln logarithms to make it much simpler. Now we can differentiate both sides, and we have ln y prime equals 3 ln x prime plus minus 1/2 ln x squared plus 1 prime. Of course, you can pause the video and try. This is a composite function. And this here is also composite, because you have ln x squared plus 1. Those are all composite functions. And here is composite function because y is meant to be y of x. So that's kind of hidden composite function, but it is function. This is usual. So I will use another color, and I will just circle this, and I'll circle this, so that's just maybe easier to see. Now, here, the derivative of this is 3 over x. Here we have to work a little bit, so this is a constant. We just need derivative of this. This here is 1 over x squared plus 1 times the derivative of x squared plus 1, and that is, this derivative of this is 2x, so the derivative is 2x over x squared plus 1. This here is a constant, and the derivative of this is 1 over y times y prime as a composite function. So have a look. Okay, so we can write y prime over y equals 3 over x minus 1/2 2x x squared plus 1. That's great. And now we just need y prime. And actually we can get it from here, because then y prime is y times this here. This are putting it here, so that is 3 over x minus this 2 and this 2 can cancel, x over x squared plus 1. Y prime equals y times 3 over x minus x squared. Now what is y? Well, y is the starting function. That is this here. So this is y. So that is x cubed over, you can write now the function, that x squared plus 1 and then 3 over x minus x over x squared plus 1. And this is the final answer. That is the logarithmic differentiation. And you can try exercise 1. So y equals x to the power 5. Let's say 2x to the power 5. And then you will have cube root of x squared plus 3. So this is your task, and try following these steps. Thank you.